I'm Ethan Kwan, and today I'm going to be showing you about could we create dark matter? Spoiler alert, maybe. Okay, so we know that 85% or more of the universe is composed of dark matter, right? And we might just be able to create it in the most powerful collider in the world, called the Large Hadron Collider, or LHC for short. So this is how the LHC works. 2 proton beams are accelerated to near the speed of light and blah, 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 yeah. And the new particle produced goes through a detector, and sometimes it's radioactive, so it will decay before reaching the detector. And this is how we know it's out there, because galaxies sometimes orbit around this stuff. Ta-da! Anyway, so here's a recap of what you all just heard. Dark matter may be made with the most powerful particle accelerator in the world. We know it's out there because, well, we think that it influences gravity on other galaxies, and kind of never mind. Yeah, and the LHC. 2 proton beams are moving in opposite directions and accelerate at the speed of light, and at 4 collision points, the beams cross and protons smash into each other. Okay, that's a big explanation. Anyway, so now you have to learn what protons are made with. Protons are made with quarks and gluons. In most collisions, the protons just pass through each other because none of the important particles inside it collide. But once in a million collisions, the components hit each other so hard that they produce a lot of new particles. Yay, boom, 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 boom. Okay, I'm getting dizzy. Can you get a peaceful scene over here? Thanks. Okay, that's enough of that. Okay, so, for example, take the Higgs boson. The Higgs boson is a theoretical particle that wasn't observed until 2012. The odds of producing a Higgs boson was about 1 in 10 million, and it only lasts for a tiny fraction of a second before decaying. It decays but scientists developed models to tell them what to look for the Higgs. They thought it would be 2 photons. So after it decays, it will decay into 2 photons. But there are a lot, and I mean a lot, of things that can make 2 photons. So the scientists came up with a solution. The answer is mass. The information gathered by the scientists allowed the scientists to go back and determine the mass of whatever it was that made 2 photons, and then they put it on a graph. If there's a big bump in the graph, it is most likely a Higgs boson, like this. And it has to be a big enough bump that it's considered reliable. Anyway, back to dark matter. If the LHC's proton beams have enough energy to produce it, it is most likely an even rarer occurrence than the Higgs boson. So it may take quadrillions of collisions. That's 1 followed by, 15 zeros, I think. Combined with theoretical models to even start to look. That is what the LHC is currently doing. That is how we will find dark matter. Or maybe it won't be dark matter. It may be something that will reshape our understanding of how the universe works. Thank you for watching this. Some of these scenes have been brought from TED-Ed. Just go on YouTube and look up TED-Ed, TED-ED. For example, this scene. Otherwise, thank you for watching. See you at howtodostuffwithethan.com, and see you next time. Bye. You shouldn't be able to see this, but I'm lazy, so I'm not gonna edit this out. Okay? If some of you are wondering. Bye.